and their great physical diversity. Perhaps it's not surprising, since Canada is the world's second largest country and has the world's longest coastline. We can look at Canada's topography by focusing on landforms. Canada is made up of three distinct types of landforms: shield, highlands, and lowlands. The highlands and lowlands are further subdivided into two regions. Canadian Shield is the geographic foundation of Canada. The shield underlies not only much of Canada, but also part of the United States. More than half of Canada is covered by the shield, about 4,800,000 kilometers squared. Some of the world's oldest rocks, 3.96 billion years old, are located in the shield near Great Slave Lake. Today, most of the shield is relatively flat with rounded hills of rock, which are actually the roots of ancient mountains. Two types of rock, igneous and metamorphic, form most of the shield. They contain valuable minerals in great quantities. Because of the vast deposits of lead, gold, nickel, copper, zinc, and other important metals, the Canadian Shield is often called the storehouse of Canada's metallic minerals. In addition, diamonds have recently been found where ancient volcanoes once existed. How are mineral deposits formed in the rock of the shield? Minerals are present in magma, molten rock, beneath the Earth's crust. As magma rose toward the surface, it forced its way into cracks and cavities in the shield rock. The process of magma slowly rising toward the surface took thousands or millions of years. As it cooled, some minerals were deposited in the magma itself. Other deposits were formed when minerals dissolved in very hot water and forced deep into cracks in the surrounding rock. This process allowed minerals to be deposited in high concentrations, which makes mining worthwhile. As the minerals slowly cooled, they separated the layers according to the density. The lighter ones floated on top of the heavier ones. Those of similar density floated to the same level. Nickel and copper are often found together because they have similar densities. Mining companies are attracted to the shield because of the presence of metallic minerals. Many cities and towns, such as Sudbury, Ontario, Thompson, Manitoba, and Yellowknife in the Northwest Territories, rely on the mining industry for jobs. The ores are smelted to remove waste materials. The concentrated minerals are shipped to factories out of Canada and other parts of the world, where they are used to manufacture products that we use every day. While the shield is well suited to mining, it is ill suited to farming because of its very thin soils. However, it is ideal for recreation because of its scenic rivers, waterfalls, lakes, rock outcrops, and vast forests. The action of the glaciers affected the drainage of the shield. The scraping and gouging action of the ice created depressions in the bedrock. These depressions filled with water to form the hundreds of thousands of lakes that now dot the shield. Because the bedrock is impervious, water does not pass through it. The glaciers deposit sand, gravel, and clay, which dammed rivers are forced them to flow in different directions. The result is a very disorganized pattern of winding rivers, lakes, and swamps. These rivers and swamps are the breeding ground for the many black flies and mosquitoes found in the shield. People visit the shield to canoe, fish, hunt, and get back to nature. The tourist industry is very important to the towns and cities in the southern parts of the shield. The shield's plentiful water flows have made it an excellent source of water-generated energy, and the pattern of drainage is affected where hydroelectric plants are located. The center of the shield is much lower than its outer portion. This gives the appearance of a saucer, with Hudson Bay occupying the low-lying center. As a result, most of the rivers of the shield flow toward its center and into the Hudson Bay. Hydroelectric generating stations have been built where the rivers tumble from the shield onto the Hudson Bay lowlands. The energy produced by these stations is transmitted by power lines to cities and towns both on and off the shield. The interior plains of Canada are part of the Great Plains of North America that stretch from the Arctic Ocean to the Gulf of Mexico. The interior plains of Canada extend from the 49th parallel north of the Arctic Ocean, a distance of 2,700 kilometers. They are about 1,300 kilometers wide in the south, but only about 275 kilometers wide in the north. The interior plains were often covered by shallow inland seas. Sediments from the shield and the Rocky Mountains were deposited in these seas over millions of years. Eventually, the sediments were compressed by the weight of the layers above into sedimentary rock. Part of the sedimentary rock deposited in these areas consists of coral reefs that formed close to the surface of the seas during the Paleozoic era. The rock layers are several thousand meters thick and took millions of years to form. Today, the reefs are thousands of years below the surface of the land. They contain much of the oil and gas found in Alberta and Saskatchewan. Mineral deposits also lie below the surface. At various times during the Mesozoic era, shallow seas covered the region that is now Saskatchewan. When they evaporated, thick layers of minerals deposits were left in the dried-out seabeds. These layers are now deep in the earth, covered by newer rocks and glacial deposits. Potash is mined from these layers and used as fertilizer in Canada and overseas. The swamps on the edges of these ancient seas produce plants that were changed eventually into coal, which is mined today. Forces of erosion have also shaped the surface of the landscape. Some sedimentary rocks are hard and resistant, others are quite soft. The softer rock erodes more quickly than the harder rock, a process called differential erosion. Different rates of erosion have caused 3 different levels of elevation varies. Each level is separated by a sharp rise called an escarpment. Escarpments form when a harder rock layer that overlays a softer layer resists erosion. Although many people think of the interior plains as flat, there are relatively few areas where this is true. The landscape is, for the most part, composed of rolling hills and deep, wide river valleys. Overall, the land slopes gently downward from west to east. Glaciation has also marked the landscape in visible ways and affected land use. The interior plains, like the rest of Canada, are subjected to glaciation. The glaciers left deposits that produced a round and gently rolling landscape in many areas. When the glaciers melted, the meltwater formed a large lake over much of what is now southern Manitoba and Saskatchewan. Later, the land rose, causing most of the water drains of the ocean. A small portion of the ancient lake remain today at Lake Winnipeg, Lake Manitoba, Lake Winnipegosis, and Cedar Lake. The floor of this lake was covered by sediments, which made it very flat. The former lake bottom was left as flat land, what is now southern Manitoba and Saskatchewan. The soil that's developed on these sediments is deep and fertile. Grain has grown in many locations in the southern part of the interior plains. The area is known as Canada's breadbasket because so much wheat is grown here. Cattle are raised in places where the climate is too dry for crops. Agricultural products from this region are used both in Canada and overseas. South of the Canadian Shield is a smaller landform region, the Great Lakes St. Lawrence Lowlands. As you might suspect from the name, the region consists of 2 parts. The parts are separated by a thin wedge of the Canadian Shield that juts across the St. Lawrence River and extends into the United States near Kingston, Ontario. Like the interior plains, these lowlands have bedrock from sedimentary rock from the Paleozoic era. The Paleozoic bedrock can be seen in several escarpments in the Great Lakes Lowlands. The best known is the Niagara Escarpment, which extends from Niagara Falls to Manitoulin Island. The Niagara Escarpment was formed by differential erosion. In the Great Lakes portion of the lowlands, glaciation has created a rolling landscape. The glaciers carry huge amounts of material, soil, sand, and gravel, from the Canadian Shield and dumped them throughout the region. The landscape is characterized by flat plains, glacial lakes, and deep river valleys. The Great Lakes are located in basins that were gouged out by glaciers. The lakes were even larger than they are today because of the enormous volume of water from the melting glaciers. They eventually shrank to their present size as the meltwater drained into the ocean. The old shorelines of these glacial lakes surround the present-day Great Lakes. The St. Lawrence Lowland was formed in a different way from the Great Lakes Lowland. The Rift Valley was formed by faulting. This Rift Valley was flooded toward the end of the last ice age by a part of the Atlantic Ocean called the Champlain Sea. The Great Lakes St. Lawrence Lowlands region is the most southerly region in Canada. It is well suited to agriculture because of its excellent soils and warm climate. The flat land is also ideal for our transportation routes and the development of cities. Because of these factors, it is the most densely populated region in Canada. About 50% of Canada's population lives in the Great Lakes St. Lawrence Lowlands, which comprise only 14% of Canada's area. Canada's 2 largest cities, Toronto and Montreal, are located here, along with 70% of the country's manufacturing industries. The Great Lakes St. Lawrence Lowlands could be called Canada's industrial and urban heartland. Around the southwestern shore of Hudson Bay and James Bay is a very flat, low area covered by swampy forest. The waters of Hudson Bay had much of the lowlands at the end of the last ice age. Known as the Hudson Bay Lowlands, this region is a layer of sedimentary rock which rests on top of each rock of the shield. The Arctic lowlands are made up of a series of islands located in Canada's far north and have a gently rolling landscape. The harsh climate does not permit farming. The ground remains frozen most of the year. However, the Paleozoic sedimentary rock which the lowlands are formed can turn to lignite in the form of coal, oil, and natural gas deposits. The Appalachian Mountains stretch from the state of Georgia in the southern United States to the Maritimes to Newfoundland in the north. They are the oldest highland regions in Canada and formed about 300 million years ago. Layers of sedimentary rock were uplifted and folded at the end of the Paleozoic era, when North America collided with Europe and northern Africa during the formation of Pangaea. Rocks found in the Appalachians of Nova Scotia and Newfoundland are similar to rocks found in Wales and Scotland. The layers of sedimentary rocks are rich in deposits of non-metallic minerals such as coal, and volcanic activity and faulting create igneous and metamorphic rock in certain areas of the Appalachians. Plateaus of this rock contain metallic minerals such as iron and zinc. Millions of years of erosion have reduced the Appalachians' once jagged peaks to rolling mountains and hills. In recent geologic times, glaciation has played a part in this erosion, grinding down the peaks and separating the hills and mountains with wide glacial valleys. During the last ice age, the weight of the ice pressed the Appalachians down. As the land sank and the ice melted, the small inlets along the east coast were flooded by the sea. The long bays that are created form a drowned coastline. These long bays provide deep harbors for ocean freighters, and some have become sites of major cities. Other settlements are located mainly in the fertile river valleys and along the seacoast. The Inuit Mountains stand like icy watchtowers in Canada's far north. In some locations, they measure over 2,500 meters in height. Their present form was shaped in the middle of the Mesozoic era when the North American plate moved northward. The Inuit contain igneous and metamorphic rocks, but for the most part composed of sedimentary rock. They are younger than the Appalachians, and so erosion has not had time to reduce them to rounded hills. They are also barren because trees can neither survive the extremely cold weather temperatures nor grow during the short summer. Vast areas are covered by ice and permanent snow. The Inuit Mountains resemble the Appalachians in composition, and, as you might expect, contain similar types of minerals. The mineral resources have not been greatly exploited, however, because the region's remote location makes development too costly when cheaper alternatives exist further south. The Western Cordillera stands along the western edge of Canada like a great wall, range after range of mountains separated by plateaus and valleys. The great height and rugged appearance of these ranges tell us they are geologically young. The collisions of North America and the Pacific plates are responsible for uplifting this region to several mountain ranges, about 680 kilometers wide. The heavier Pacific plate forced its way into the lighter North American plate, causing much folding, faulting, volcanic activity. The result was the Western Cordillera. The mountains and valleys of the Western Cordillera run in a north-south direction. This presents an obstacle to transportation because main travel routes across the Cordillera must run in an east-west direction. There are only a few passes or gaps in the range of the Cordillera which are low enough to allow highways and railways to cross over. Since it is mountainous, the Cordillera is lightly populated. Most people live in farming and mining towns located in the river valleys, Vancouver and Victoria. The largest cities in the Western Cordillera have long flatlands close locations. Towns such as Banff and Jasper thrive because of tourists who come to see the beautiful majesty of the mountains. The glaciers in the mountains of the Western Cordillera are the only remaining glaciers in Canada, apart from those in the Arctic. These glaciers add to the beauty for which the Canadian West is famous.